Hello and welcome to this month's podcast. My name is Javier Solsona and I'll be showing you how to create kind of a sphere of influence so that whenever we drive an object, another object will be driven on a different attribute, but from a sphere inside a sphere. So we don't want anything to happen inside here. We want everything to happen kind of in the outer sphere. We're going to start by creating a sphere and a cube. So we'll create our sphere, that's the one that we're going to drive, and also a cube, that's going to be our driver. We're going to move it a few units down in translation X. So we have our two objects. Now we're going to be using a distance node. They're really great in order to be able to just calculate distance from one point to the other, but it's really all on 3D. So let's just take a quick look at it. If we create a measure tools distance, we can snap one to one point, the other one there, and then that's our distance. We can see that our distance from one object to the other, it's 21 units, 0.33. Now if we grab that, if we move it here, of course the distance gets closer, but we can be anywhere here and we're just going to get one distance. So that's going to be our sphere, because anywhere in any angle here, it's going to be the same. It's going to give us a nice value. So what we need to do is our first locator, let's hide those. Our first locator, we're going to keep it in world 0, and the second locator, we're going to parent it to our cube. So now we can move our cube, that's our driver, and everything comes through. So what we want to do is normalize this distance so we get a value of 0 to 1, and then what we'll do is we'll apply that to a multiplier so we can actually get the translation y of the sphere going up and down. So the way we do that, we can create a multiple divide node. So with a bit of meld here, we go create node, multiply divide. So now we got a new node. If we open the attributes, we've got a multiple divide, and right now our operation is multiply. What we want to do is divide. And what we're doing is we're going to be dividing the distance node by the actual distance right now. The current distance right now is 0.333. So an input 1 will be applying the actual distance. Now, when we're dividing one over the other, right now it's going to be the same, so we're going to get 1. If we are halfway through, we're going to get 0.5, and that's how we are going to be normalizing our distance. So to do that, we use a connection editor, multiple divide. We grab it we load it on the right side, and the distance. And we need our actual distance. We can go down 1 to the shape, and the distances can be found in the shape, and we put it on input 1. Now we got our multiple divide with all those both values going in and out, and now so if we connect that directly to the sphere, we're going to get a value of 0 to 1. What we're going to do is use a multiplier, so we are going to create another multiple divide, create node, multiply divide, and in this one here, what we're going to do is, again on our connection editor, we grab it on the right hand side, we want the first one, let's find it here, first multiple divide, load it on the left, and then we're going to connect the output of it into the input 1x. Here we go, and then make sure that this is multiplying our operations, and then we're going to multiply by around a value. Right now we can do 10, just so that we can see a big difference on the scale. Now once we got that, we can again connect the multiple divide, the output of it, to as simple as the sphere's translation y. Output translation y. There we go. So right now what we get is when the distance is 21, we're going to get the sphere at 10. When we get closer, we get at 0. So, and of course we could have done a set-driven key, but this actually will give us a bit more options later on when we do the sphere inside the sphere. And also, instead of using a value of 10, we could potentially come here and then add an attribute, and we can say multiplier. We'll leave it open. Let's do a default of 10 for now. So we do a connection. We're going to have our cube, we're going to have our multiplier, and we can connect to the multiple divide on this side. Right now we have put a 2, a 10 there, but now we're actually making a connection. So now we get the same result, but we can also animate this. So if we want to go 15 when our value, then we're going to get that. Now the problem with this is that this carries on going forever. Now we might want to actually stop it whenever we hit our maximum distance, which was 21.33, to actually stop at 15. To do that, we can use a clamp. We can create a node, clamp, and clamp has a few options here: minimum, maximum, and the input. So what we can do is the maximum. We can use our value that we were using before from the cube, and then we got the multiplier. That's going to be our maximum. The minimum we know is going to be 0 because we want it to be up to there. And then the input, what we're going to get is the output of the multiple divide, which is right now we're connecting it to the translation y of the sphere. We want this one to be our input. So we load that and then we get it on the input. Now the output of this, because we know it's going to get clamped from 0 to our maximum distance, in our case I think it was 10, then it's going to be from 0 to 10 and then stop there. So if we grab our clamp, where did our clamp go? There we go. We load it here. Now we're going to get our output to be translation y of the sphere. Okay, now we got 10. We're going to go back to 10. So now we go from 0, 10, and then we stop there. So again, this can be used for driving anything, say like a joint on an autoclavicle or something like that. And we are giving a bit of control to the animator to change the multiplier. So, but this is all the way from 0 to 1 to 0. Now, what happens if we got all this distance, but we want to go from this point here to that point there, from 0 to 1, and then from all inside here to be also 0. So I've got a couple of pictures here. So we got, this is the first one that we've done. So we needed the distance. So anywhere inside here, we're gonna get the values going from 0 all the way to 1. So from 0 all the way to 1 the other way. So what we want to do now is do this one where we want from 0 to 1 and then all inside this circle here to be 0. So we still got our distance all the way here, and then we got our minimum and our maximum. So the way that we do this is we got a little formula here, and it looks kind of scary, but it's not too bad. It's the distance minus our minimum value and divided by the maximum distance minus the minimum distance. What this will do is this will normalize this distance from here to here. So we're going to get a 0 to 1. And then we're going to clamp it again, 0 to 1, because we don't want to go a lot higher than here. So this is what we're going to replicate on our setup. What we're going to do is add, we really don't need the multiplier anymore, but we'll just leave it. Actually, what we'll do to make things easier, we'll just open one file I already have with a minimum distance and a maximum distance. So we know that this is going to be 1, and then when we hit 5 down here, we want the sphere to be at 0. So in order to do that, we got our formula. What we can do is, of course, we can do it all with nodes, which is probably the preferable way to do it. But just to make things easier, we're going to create it as an expression. So what we have in the expression is the inside the sphere, and that was the distance, the shape, minus the minimum distance, divided maximum distance minus the minimum distance. And this was the picture that we had right here. So distance minus minimum, maximum minus, so we're getting all this value inside here. Once we have the value, we just apply a clamp from 0 to 1 of that value here, and then we just apply that to our translation y. And we are going to use a multiplier. Right now, again, we're using 10 as a multiplier. We could connect this to a multiplier in our cube. So we create it, and what happens here now is when we are in the maximum, our sphere is at 10. When we get closer, now we get into 5, hit 5, and the sphere is at 0. And then all inside here, and of course this is 3D, is in 0. We can change that so that our minimum value, let's say, is 10. So as soon as we hit 10, so our sphere is the inside sphere is a lot bigger. So again, this is something I've used this in the past with autoclavicles, where I wanted a certain bone to be rotating relative to where my IK handle was, say. So by doing this, I could control especially the sphere inside the sphere, and then I could get them set up to work properly. So there we have it. Hope you enjoyed it, and we'll see you next time. Thank you.